where you are. This is Eddie Casado. I'm the Affiliate and Technology Partnerships Manager at Convert. We are an A/B testing platform with more than 15 years in the market. Today, we're covering a very, very, very exciting topic, which is return to basics, analytics, and interpretation in A/B testing. I am not going to be doing the talking today because we have somebody that is way more qualified to talk about this. Ellie, thank you so much for joining us. How are you doing?
I'm good, thank you. How's everyone doing their morning, afternoon, and evening, wherever you're dialing in from?
Doing well, doing well. Ellie, I want to do you justice. So instead of me introducing you, why don't you please introduce yourself to the audience?
Sure. So I'm Ellie. I'll just move on a slide. I'm Ellie. I'm the head of consulting at a small experimentation agency in the UK called Eclipse. My background is about 13 years of working either in-house, agency side, or vendor side for lots of different experimentation worlds that I've worked for, and that's always been a blend of experimentation and data. Sometimes I've come in to fix the experimentation, sometimes I've come in to fix the data so that we can do experimentation, which I guess is where this topic kind of comes from, because you need some essentials of data to be able to do good experimentation. I'll move on to what we're going to cover today. And also, please keep up in the chat. Vlad is asking everyone to kind of introduce yourself. So if you're there, please do message in. Let me know, especially if you're more of an analyst or more of a different role. That'd be really good. So what we're going to cover today is some essentials of A/B test setup, just the very basics, some things you probably already know for some of you if you're more experienced. Looking a little bit at how we collect data. Are you targeting the right users? What's your scoping? What's your tagging that you should use? And then analyzing and interpreting results. So we'll do a little bit about sample sizing and knowing whether you've collected enough data, and then also looking at some experiment results and interpreting. We've left enough time at the end for any questions, and they can be in the chat, and Eddie and Vlad will help curate anything that anyone shares on the session as well, and make sure that I stop and answer any questions if we need to. So I'll get on with our first section, which is about A/B testing setup. So what is an experiment? Starting from the absolute basics, any controlled manipulation of one or more factors where their effect on a result or outcome can be measured in order to validate a theory or hypothesis. Some examples of things you might hear in the business: the quality of their website would be better if it was coded in this code rather than this code. We'd make more money from our site promotions if we offered them on all of the product pages as well as the homepage. The teams would work faster, deliver better if they used method X for sprint planning. So that's an example of like an organizational experiment that you might want to run. What is the benefit of A/B testing? So you can test your theory and mechanisms. Is my theory correct? How does it work? Which version is better? You can understand the magnitude of an outcome, but also the trade-off. Imagine that you had conversion rate and margin that you wanted to try and improve, and actually one experiment only improved margin and one only improved conversion rate. Which one's more important to you? You can evaluate large-scale changes and policies. For example, if you need to change something globally across your entire site, you'll understand the effect, and is it just one tiny part, or is it the whole that's actually affecting everything? And then fact-finding. Sometimes you don't come in with a theory. You just want to know that something that you have to roll out or that you're going to do is not going to break everything. You might be making an SEO change, for example, and you want to make sure that that's not going to break anything from a conversion rate perspective. You don't want to miss out on an opportunity to innovate or learn. So what is A/B testing, multivariate testing, personalization, and segmentation? So in classic A/B testing, a visitor arrives on the site, and the A/B testing tool that you're using will split the traffic 50-50 between A and B, or if you've got an ABC, it'll be 33, 33, 33. Only one part of the page is varied. You're just doing one thing at a time. And then your analytics tool tracks the behavior of the users. You talk about the improvement in terms of uplift. So 5% increase in a conversion rate, for example. Multivariate testing is when you change multiple things at the same time. So you kind of have more than one hypothesis happening at the same time. Is it the banner? Is it a clickable button? Is it also the image? And you try and change those in combination together so that you can find the best combination. This is really useful, especially if you've got, say, you're changing a price, you're adding an offer code, which are kind of more sort of cross-sell, upsell pricing testing, but you're also changing the layout of the page. You then know the exact combination of which offer code, which price and which layout is going to be the most successful for customers. Personalization is where you actually look at some attribute of the user as they arrive on the site, and then you personalize the experience to them. So some examples of things that you could personalize would be, are they a customer or prospect? How many products have they purchased, their purchase history? Is there some on-site behavior like the traffic source, the keyword that they came in from, the time of day, like maybe you only want to target something to the weekend or out on weekdays only. Also derived segmentation. So that means things like, we know this type of user has a propensity to convert in this particular way, so we're going to show them a different price, for example. Thinking about how these different methods compare. So expert judgment is just launch it. So it's really easy, it's really simple. You can just get stuff on site, but there's no accountability. You don't know what's happening. There's no statistical approach. You can only do that kind of pre and post analysis. And then you're probably going to end up in an argument with someone because they'll say that it didn't improve anything and you'll have no data to support your ideas. A/B testing at least is a small improvement. You're considering what you're doing. You're introducing that basics of statistics. You're measuring the effectiveness of what you're doing. But you haven't targeted any users in a particular way. And actually, if you were to do lots and lots of sequential A/B tests, it wouldn't be as good sort of from a cost perspective than trying to kind of combine experiences together, which is what the benefit of multivariate testing is. You can test 2 or 3 hypotheses at the same time with the same amount of traffic, so you're more efficient with the traffic that you're using. And then finally, segment-based means that you're segmenting as well as testing. So perhaps as the user lands on the site, you would customize the landing page for users from a particular traffic type, and then also have multiple variants happening on the page. So this is the most complex one. And as you move from left to right, you go from sort of lower complexity to higher complexity, but also less statistical rigor to higher statistical rigor and more personalization as you move from left to right. So early on, when you first start testing, probably you'll only run a small number of A/B tests per year, and that's completely fine. That's completely normal. You want to start adopting your tool as quickly as possible, trying to get in there, trying to get a few things built. They can be really simple. And as you increase in your maturity, as you sort of build that muscle memory for building tests, you can then produce a more mature roadmap as you go and actually start to build in A/B tests and multivariate tests. If you're not multivariate testing now, don't worry. You don't have to, but it can be more efficient if you want to understand the answer to 2 things at once. Like, I want to know if the banner makes a difference at the same time as the text, and I want to know what the interaction effect is. So that's the benefit there. And then on the right, I've just depicted like the difference between speed and scalability. You can go a bit faster with A/B testing, but it's not as scalable. You can't do as many hypotheses in a year. So next we'll move on to how we're collecting data. So this is a mixture of looking at how we actually tag the page and the site, and then also how we're actually looking at what metrics to collect and what we're grabbing from the site as well. Warning, there is a little interaction in a minute, so be ready with your fingers on your keyboard, just in case in about 4 slides time I will ask you a question, so be ready. So how do you ensure you're collecting the right data? So how many users you allow into your experiment is called targeting or scoping or using an audience. Imagine that you only want to show like a really deep discount to specific users who are new and they come from paid search or social, and you don't want that heavy discount to be shown to all users. If you allow all users to see it, it will really pollute your data. You won't get a really good answer, but also all these people who shouldn't be seeing this experience are in the experiment, and you don't want them to have that experience as part of visiting the site. You don't want an existing customer to get a heavy discount because they're already an existing customer, potentially. So thinking about how you plan your experiment scoping, if you just wanted to have something like a promotional banner, you know, with like a coupon code or something in it across every single page of the site, you didn't care which page it was on, you could scope the experiment on all of your pages going through the funnel like this. However, if you just wanted to pick out the product details page, it's only relevant for one page. You therefore need to pick an audience and scope it to just that page and exclude everyone who's not visited that page. Then imagine it was just a pop-up that opens on click. Well, you only want people who click on that pop-up to trigger the experiment entry. So you can't include everyone who's on the page. You need to just include when that pop-up opens. So you may need to fire a tag or specifically scope the experiment to an audience that only activates when that pop-up is clicked. And that's really, really key. And I'll show an example of that in just a second. And that's why you need to use audiences or targeted tagging to activate users into an experiment. So in this example that you can see on the right, this audience has been set up as Google organic traffic. Basically, people come from Google, they've searched, and they're landing on the site. You want to check the volume of people who are coming in as you do it. And also, this is one of the things that you could do when you first set up your A/B testing tool. You can run an AA test to check your audiences. So turn it on, same experience in A and B. So that's what an AA test is. And then you can run all of your different segments, run all of your different audiences, and check that they're all populating and that you're getting the right kind of numbers in all of them. And that's sort of a best practice for actually checking your tagging and everything on your site and stuff as well. So this sounds great, but what could go wrong? So this is the interaction slide. Apologies, everyone. So on the left, you can see this is a very old experiment that I ran about 10 years ago for O2 when it was still O2 Telefonica. On the left, you've got the control. On the right, you've got the variant. The first question going in on the chat, who can spot the difference between the two? I'll give everyone like 10 or 20 seconds. So what's the difference between the control on the left and the variant on the right? And you might have to study this a little bit. I can see a few people on the chat. So it's the little interaction. Yes, exactly. So the little interaction you can see where someone started typing 2 letters, IP, and on the left-hand side, it gives you a list of iPhones. And on the right-hand side, it gives you iPhones and pictures. But could you guess the potential problem with this test, given what I was just talking about in terms of scoping? Can anyone guess what might have gone wrong with the scoping of this experiment? Go on, give me two more little answers. Yeah, some good answers. I'll give it another. Yeah, I'll give it another 10 seconds.
So for the sake of anybody that's going to be watching this after the fact, Ellie, can we read the options that people are giving us on the chat out loud?
Sorry.
Thank you.
So we've got, the first question I asked was about search results. So people correctly guessed that on the left, you've got the little list, and on the right, you've got the images. And then a few people have said, not everybody will search, existing customer traffic versus new traffic. It tests more than one change. There's fewer search results visible on the right-hand side in the variant. You see the price in the top picture. Not all will see tests because the users may not search. So there's some really good answers in here. And to be honest, I think people have nailed it pretty quickly. So actually the real problem is, yes, that it was to do with the way that the page was tagged up. And I'll explain that in just a second with like a numerical answer. But essentially, the most important thing is once you've built an audience, you need to check the volume of people who are in the audience. Because in this instance, we had included everyone in the page in the test, but it turned out that only 2% of users actually clicked into that search box and started typing, because you only saw the experience if you started typing. So if there's a certain number of people on the page, a specific number actually click into the box, and then an even smaller number actually start typing once they've typed into the box. And I think 2 or 3 of you nailed this perfectly. So the entire website had about 1 to 2 million unique visitors per day and a base conversion rate of 1%-ish, because it was like the whole site. This specific page had 500,000 to 1 million unique visitors a day, and the base conversion rate was 2% or less. The number of people who clicked into the box per day was 0.5 to 1%. So that's less than 5,000 users a day. So that conversion rate was incredibly small. And we realized that actually the targeting of this experiment was completely wrong. We had included everyone on the page when such a small number of people had actually clicked in. And it would be a little bit like if you were trying to detect a tiny ripple on top of the Hokusai wave. You were trying to actually increase uplift in something that was already like a massive tidal wave. So very difficult to detect. But also we realized the number of users seeing this experience was so small, we were never really going to get a clear result. This was one of those ones where it would have to run for a really, really long time. And actually, what we realized is that we should have sample sized our experiment better. We should have known what scope we should have done, and then actually sample sized our experiment better, which is how we come on to my next section, which will be about sample sizing, or how many users should I allow into my experiment. So analyzing and interpreting the results. Sorry,
Ellie, if I could, yeah, sorry, if I could, can you guys hear me okay?
Mm-hmm.
Great. So are you going to cover the correct setup now? Or can you just mention what the correct setup was for this experiment to actually work and be valid?
So the correct setup would be you only allow users into the experiment if they have typed into the box and have put at least 2 letters in the box. Or you can trigger an additional tag that says activate this experiment. The first one is slightly better, but if you can't do the first one because the interaction on the page is such that it's very difficult to detect that it's happened, you can fire a separate tag to your experimentation tool that says only activate this experiment at this moment, or you can send it separately to your analytics tool as well.
Okay. And then the hypothesis would have been to actually validate whether people searching in these 2 different type of search results would convert better towards purchasing a device. Is that what you were trying to validate? Okay.
I think what we were trying to prove, if I go back to the experience, is that when you're typing on the left, there's lots and lots of different iPhones that come up. How do you distinguish between them? So in theory, the experience on the right. I know the prices show 0, by the way, but that's just because it was a test experience. There would have been real prices, but this was a QA screenshot. So the idea is that you could very quickly scan the results and go, oh, well, I don't want a black phone. I want a white phone. I want a gray phone. Or you could quickly scan the prices and kind of determine, oh, it's a newer iPhone and it's more expensive, that kind of thing. But in the end, we ran this test twice. We ran it the first time when we made the mistake, and then we ran it the second time with the correct scoping of the test, but we didn't get a result. We ran it for like 10 weeks. And it was just like non-significant the whole time. We didn't get a clear result from it because the number of users getting into the experience was really small. But what we also did was we diverted away from doing as many tests on the homepage unless they were really big. So the homepage has a lot of unique visitors, but actually, because the conversion rate from that page is really low, detecting an uplift is really, really difficult. So what we diverted away towards was doing more things deeper in the funnel where the conversion rate is better, and actually you can get to statistical significance more easily. So that's kind of how we ended up filtering on that. So
thank you, Ellie. I think this goes to show how incredibly important it is to actually, one, be okay with making mistakes, right? Because that's the first thing. It happens, and sometimes, especially when you're dealing with data and all this different nuances and navigation, these things are bound to happen. So it's okay to fail. What's more important is actually how you get up, right? It's not about falling down, but how you get up. That's the first thing I can call out on this experiment. And the second thing is how important it is to critically think about the funnel, the user journey, what are the different things that users are exposed to, and actually nailing down what is it that you want to measure? What is it that you want to validate? Because I mean, when you look at these 2 different search results, I can think of a million things that couldn't influence the results, right? Like the sorting, what iPhone do you put on first, and all of these data points, which I think goes back to collecting data. And the next step of this presentation is going to go into is defining this different guardrails. So thank you, Ellie, for answering these questions. Appreciate it.
No problem. It is quite a complicated one, and because it's more on the tagging side rather than on the classic analytics side, because one of the questions that we got when this test result came in the first time is, can't we just go back and strip everybody out of the analytics who didn't see it? And the problem is, when you do that, you can invalidate the results. There's loads of statistical reasons not to do that, which are kind of complicated. One is called Simpson's paradox, where you end up with a different result when you look at something at a segment level versus a total experiment result level. But in this instance, there was really a lot of variation in how many people were activated into the audience from control to variant just because the numbers were so small. So a difference of like a few hundred people made a big difference in terms of unique visitors. And so actually it meant that created a lot of statistical issues and we couldn't extract the users out afterwards. So it made the initial run of this experiment essentially unusable data because we had so few users who were actually interacting with this. It gave us the data point that said so few people are interacting with this, basically, as part of the experiment. So I'll move on to looking at the sample sizing. So I will kind of allude to this example a little bit when we talk about sample size as well. So analyzing and interpreting the results. So how do I know I've collected enough data? So an experiment allows us to sample a small number of users so that we can infer about a bigger population. So whenever you're running an experiment, or even whenever you're running any sort of analysis, you're taking a subset of the data and then you're trying to extrapolate out more broadly. Our statistical approach when we do A/B testing is it just adds a little bit more rigor because we're controlling for things like seasonality, anything that might be launched at the same time as your experiment. It will, even paid traffic changes, someone suddenly turns off some of the paid marketing halfway through the test, that will affect both variants equally. So you're controlling for all of these problems. Year on year, we're all being affected by AI affecting our search results, how often we come up in search results and our volumes of traffic. Well, that will be influencing our control and our challenger equally. So how many people do we need to have in our sample to enable us to accurately infer about the broader population? So we're doing a bit of a return to basics today. So we're going to focus on a frequentist inference example. If you want to talk about other schools of inference, there will be other sessions that I'm sure will happen that are focused on other kinds of inference that you can look at. So in this instance, the classic frequentist example would be a simple coin toss, as you can see here on the right. So the probability of flipping a coin and getting heads is 50%, as we all kind of know in our heads. And that's the true value that actually, if we keep sampling, we'll eventually get to. But how much sample do we need to collect in order to find the true value? So if you look at the graph on the left, if you take 10 tosses, 10 times 10 tosses, so you've done 10 tosses 10 times over, we don't see that 50% probability coming out in the results. We see real variability between 30% of the time getting a heads and 80% of the time getting a heads. And actually, if you do 100 times 10 tosses, you start to see that increase in frequency, that repetition of how often we're sampling, it starts to bring that closer and closer to the 50% that we expect to see. So that greater sampling narrows what's called the confidence interval. And the confidence interval is almost like that breadth of variability. You can see the breadth on the left is really high, like you can see that it's much more variable, and on the right it's much less variable. So it's a measure of accuracy, and it tells us the range in which the true value that we're trying to sample for lies. And why is it critical for A/B testing? Well, if the sample is really small, then it won't accurately represent the population. If it's too small, you're basically wasting your experiment. So our example that I showed earlier, that was a wasted experiment because we had sampled incorrectly. The larger the sample, the closer it'll be to approximating the population, and its largest, the sample would be the same as the population, which we wouldn't be able to do in A/B testing because you'd have to extend an experiment infinitely over the entire duration of your website. But if it's too big, you could waste resources unnecessarily to get learnings. You could run an experiment for 6 months and learn the same answer that you would have done in 4 weeks. It allows you to uncover and measure differences with confidence, and it also helps you control the risk of making the wrong decision. So there's this concept called false discovery rate, which is when there isn't a change in the population, but because of your sample, you think you've discovered a change in the population. Or missed opportunity rate, which is in your sample, you haven't found a change, but in the broader population, there was a change. And so those are two types of error that we try and control for using what's called statistical confidence and statistical power. So I won't go into that in too much detail and explain them. We can always have a separate stats focused session that's really focused on those. But that's why when we're talking about sample size, we have these controls, like a type 1 error, type 2 error, as it's sometimes referred to, or statistical confidence and statistical power. I can see Eddie's unmuted because he's going to ask me a question.
Yeah. Good catching that one. I do want to ask you something that kind of, I am not an expert at CRO. I am I would say enough to be dangerous. I know enough to be dangerous. So my question is, you talked about confidence and that range you have, that variability. I've always understood that as being the standard deviation. Is that the same thing, or does that the concept of deviation is what you call confidence, or is a different thing, or how do you define those two?
So they're slightly different. So when you when you calculate the statistical calculations that you use when you're doing A/B testing, so there are different types of statistical tests you might use, like a Z-test, a t-test. Like any of you who maybe did biology at school might have done a chi-squared test, or
Failed
might
it
have done
very bad. Failed
yeah,
it all the time.
yeah.
So
Don't worry. But in each of those instances, there's always a calculation that expresses some factual value that you need to find, and you're testing against that factual value. So when you define your statistical confidence that you want to achieve in the first place, and then when you output a p-value at the end of your statistical test, you're kind of comparing them with each other. And essentially the confidence interval shows how much of an overlap of the sort of margin of error of the two results could be. So when they're closer together, A and B, they'll have the same, like if you imagine a bell curve like this, A and B, the potential range that they could be in will be identical if they're very close to each other, and you can't declare a significant result. There's no evidence to reject the null hypothesis. But once they become significantly different, there's no overlap in their kind of error. You know, when you drew box plots at school and you'd have like the X's and stuff at the top and bottom, they would slowly move far enough away so even the X's won't overlapping each other. When that happens, that's kind of what the confidence interval is helping you to detect. It's helping you see that there's enough of an interval between the two experiment results. That's one way round of explaining it. There's loads of other way rounds of explaining it. Like I think depending on who you talk to and what kind of upbringing they might have had or what they got taught at school or university, they might explain it in a different way. But that's one way of thinking about it. Like my two results are far enough apart that I can distinctly see that they're different.
Okay.
So that's
Well,
one
I
way
think
around it.
I think you were right. We need definitely a different session to go into all these things. But I did wanna ask you that question because it's something that came up while I was doing some CRO, that you have this variability on conversion rates. Let's say for one channel, for organic search, for example, you have this variability of conversion between 6 and 10%, and you have to calculate what is the actual benchmark that you need to strive towards to say whether an experiment is valid or not. But we can save that for another session. And then the other question I did want to ask you is that you were talking about defining the audience or the size of the sample or the universe of users. How do you actually do that if you're just starting out, or if you're just like, okay, so I'm about to launch my first experiment? How do you know what is the true size of the audience that you're impacting?
So I suspect most of you will be using something like when you get started, if you've never run experiments before, you might already have a product analytics or web analytics tool on your website. So let's say you were looking in Google Analytics and you could say, right, I want to know the size of the number of people who are on my site. So you'd go in and you'd set two predefined dates. Very specifically, make sure you look at number of unique visitors or users. Don't use session-based metrics. We can do a whole separate session on not using session-based metrics. But for statistical testing, the counts that you include in the test have to be randomized and independent. And session-based metrics kind of breaks that principle. It's okay when you go into other types of statistical tests in other parts of the world of statistics, but because we're looking at just frequentists today, you need to keep that independence of your observations, and that the two sets of data, A and B, need to be randomized, and that there's no kind of like interdependence between them. So don't use session-based metrics, but let's say you're looking in Google Analytics and you look at the last 6 months of data, and you see the number of unique visitors, you divide that by the number of months, and then you can see the number of unique visitors per month. So that's how I got those numbers I referenced earlier. We looked at the total number of unique visitors over a long time period so that I can include seasonality, natural variation, natural change, and then I divided it so I got an average number of unique visitors per month or per day. And then you also want to do the same thing for conversion rates. So I've got the conversion rate calculation plotted out towards the end. But basically, you would have the number of unique visitors and then the conversions, and you would divide one by the other to give you your conversion rate. And you can see your average conversion rate within a specific time. Now, the standard deviation that you mentioned before, there will be a natural variation in the conversion rate, and it will be more variable the smaller your numbers of unique visitors. You'll see like higher variability. But you include not standard deviation, but variance, which are related to each other. The variance is the square of the standard deviation. That's included in most statistical test calculations. So that means that when you're calculating your errors, your standard error, that is actually included when you're doing your statistical test. So in theory, it will also affect A and B equally. So if it's really variable day over day, it will impact both in the same way.
Thank you, Ellie.
Like a couple of questions in the chat, I think. Oh no, it disappeared. Okay. Well, if you still have that same question, you can pop it back in at the end. We've got time for Q&A at the end. Got plenty of time. So that was me attempting to explain false discovery rate and missed opportunity rate. There is like quite a nice diagram that I can maybe share in the resources after this, which explains how you get to false discovery rate and missed opportunity rate. But again, it's one that's good for a statistics session if we want to do a statistics session after this one. So how do you calculate sample size? So we've got the confidence level of the experiment. So I just talked about that. Confidence controls the false discovery rate. So when you set it at 90%, you're getting a 1 in 10 chance of a false discovery. And then the power of the experiment controls the missed opportunity rate. And we normally use 80% power. And that's because in the online world, we live in a different world than, say, in medical testing, where it's way more important to know that someone doesn't have a disease and that we've missed a diagnosis of a specific disease. They might set the power much, much higher because they will have a smaller sample size potentially, and they have to know that someone definitely does or doesn't have a disease. And it's worse to accidentally tell someone they have a disease when they don't than to miss the diagnosis of a disease when they do. Whereas in A/B testing, we'd much rather know that we're not detecting some false thing in the data than accidentally miss an opportunity. You know, you'd far rather know that you're wrong than you're right, if you see what I mean. So then the other thing you need to know is the relative lift that we'd like to resolve, what I call the experiment size or depth, so the number of variants. So is it an AB, so there's 2, or is it an ABC, so there's 3? And then the conversion rate of the page. So when it's a bit closer to 0% or 100%, you might require more sample because you're trying to detect something that's either very, very, very high or very, very low, and you're trying to detect quite small changes. I can see there's a question in the chat. Eddie, do you want me to take it now?
Please do, Ellie. Let's take advantage of the question while it's hot.
So the first question is, what is your take on multiple tests running in, for example, a booking funnel? How high is the risk that they influence each other? So this is a question I get asked a lot because a lot of literature out there is around interaction effects and the problem of having multiple tests running at the same time. I would say different people and different A/B testing tools give you different advice. So that's slightly confusing, but I'd say there's a couple of schools of thought on it. Some people are like, well, you know, if you're booking.com, we don't care. We'll just run thousands of experiments at the same time, like in the nicest way possible. They have some controls built into their statistical platform that help them detect it when it's really bad. But in theory, as long as it's not a super negative interaction between 2 tests, you should be okay. But that's the point, is they're at the size where they don't care, right? So I think the advice that I quite like following, I don't know if any of you know Matt Gershoff from Conductrix, but there's a quite nice quote from him where he talks about if an experiment is super duper important to you and you need to really, really precisely nail the revenue figure from an experiment, like I need to know explicitly that it was much higher for the variant, it is worthwhile turning off the other tests or having it so that it's mutually exclusive. So let's say you put, let me put the, there we go. I've just put that in the chat. I'll put his name in the chat. So he's just one person that I've read lots of quotes from. So there are lots of other schools of thought as well. But one of the nice ways he put it was, if you care less about the concurrent tests that you're running. It's okay to have multiple tests running at the same time. But if there's a specific test that you really need to nail the numbers for, you can either do what's called a mutual exclusion. So that test gets its own traffic that's unpolluted all on its own, and then you let all the other tests go into another set of traffic. So you define it at audience level and set up a mutually exclusive audience, or you turn everything off for that 2-week period when that test is running and you let all traffic go into just that test. There's a bit of literature I read by Optimizely a few years ago where they were like, well, in theory, every single test that's running in your booking follow funnel will impact every other test that's running equally. So actually, it kind of doesn't matter. That even, I think the only scenario where it really matters is, let's say you were running an A/B test which specifically diverted traffic from in the B variant away from a page, and then you had an experiment on that page. That would be a negative example because you would be reducing the sample size on that other page. Another one would be if you've got 2 on this test on the same page and they don't work well together, and you should have QA'd that out in the first place and spotted that at the beginning if you were going to launch those 2 tests at the same time. I don't actually think it's too much of a problem as long as you've done what's called dependency mapping. So you've actually looked at what else is running at the same time. Is it on the same page? Is it affecting the same KPI? And I think overall, you're normally fine within reason. But get your QA team to double, triple check if you know there's going to be 2 tests running at the same time, that it can work at the same time. I think your other question you've put here.
I have it here. Positive lifts in A/B test after rollout. This is really disappointing. What is your take on this problem? Makes it difficult to justify investments into testing if management does not see the positive results. And she also mentioned that Booking.com always gets quoted in when covering this topic. So any experience, Ellie, that we could share with Suzanne and the rest of the people on our session today about this problems arising on lower traffic sites, and how do you solve for them?
Well, I think nearly everyone is not of their size, basically. So nearly everywhere I've worked, like I used to work for a B2B travel company. I used to work for an online photo product printing company where we had much smaller volumes than you get at Booking.com. So nearly all of my brand side experience is working for much smaller sites, but I've also worked for clients who are quite large. So I've got a complete mixed view. I would say in terms of solving the problem around rolling something out, I think it really, I hate to say this, but it depends on the type of change it is. So there are types of test changes where you will see a noticeable difference during the test. And the idea, people talk about that kind of feature blindness idea, where after a little while, people stop seeing the effect. I mean, that's happened to me. I've had tests before where we've changed a banner on the site, and initially it's made a really big impact and we made a lot of money from it. And then when we rolled it out, we haven't seen anywhere near as much of a change. One thing I would do is when you're controlling for the revenue figures that you quote, as much as possible, try and quote margin, not revenue, and try and allow for a margin of error on your revenue and margin figures. So for example, because you're doing a statistical test, the true value is in the middle and there's a plus or minus, which is a margin of error. Take the lowest one, and then also if you can, try and take out some of your product costs or any of your COGS or things like that, so that you go down to like the margin rather than the revenue. So if you are then promising the business an increase in 100,000 in margin at the very bottom of that margin of error as well, rather than promising a 1 million increase in revenue or profit, they won't see a 1 million increase in revenue or profit when it gets rolled out, because all the product costs and stuff like that, when it gets launched to 100% of users, that will start to eat into the amount that they'll actually see in the final numbers. So that would be my recommendation in terms of that kind of reporting of the numbers. And I don't want to do a whole session around potential value calculations because everybody does it differently and everybody does that kind of ROI modeling differently. I prefer not to do it. I tend to quote the difference in the variant and the control during the test period that was observed. And I'll say that's how much of an impact this experiment has made. And I don't tend to then model it out over the whole year. I just say that's the difference that has made as a one-off. And you could kind of bank that small difference. And it means you're trying to kind of bank this absolute smallest amount of money physically possible so that you're not overestimating. And then people won't challenge me and say, well, I didn't see £1 million increase in revenue. I'm like, no, because the difference between the challenge and the variant was only £100,000, for example. So that's kind of how I address that. I don't know if that necessarily helps your specific problem, but I would say there's lots of literature online you can read about potential value calculations and doing ROI modeling. And I think Convert might have an article about this somewhere online. So maybe that can be shared at the end, or when we send out sort of the resources afterwards, we can send some examples of how to do that. But that's definitely the way that I would think about doing it.
Thank you, Ellie.
Do you have any questions for me before I move on
No, just trying to keep track of time, being mindful that we have 20 more minutes for the session, and we may have some time for Q&A at the end. So let's just keep going through the presentation then.
So in terms of determining the amount of sample that you need for a specific experiment, so if we've just talked through doing sample size on this slide, so when you do sample sizing, the simplest way is to use an online test calculator. So collect the information that you've got here on the left. And I won't recommend a specific one because everybody has got their own. So if you just type into Google A/B testing,
just use Convert. Yeah, use
exactly.
Convert. Ours is really good. So
there you go. Exactly. So I'm tool agnostic. So you can look for one on the internet that will help you, or you can go A/B testing calculator Convert, and then you will find the Convert one specifically. So collect these things that I've got listed on the left that you'll need to know in advance of going and visiting that page, or once you've searched for it. And then this is how you get your sample required. So let's say you run this amount through the A/B testing calculator, and you know that you've got 5,000 unique visitors a day, and you want to detect a 2% lift. So let's say your base conversion rate is like 20% or something, 5,000 users a day, and you want to detect 2% lift. So you need 700,000 users. So someone can go ahead and triple check that it's 700,000 users. I think I made that up. So 700,000 users. To determine the experiment duration, you would do that divided by the amount of users per day multiplied by the number of days in a week, and that will give you the number of weeks. So on the right there, you can see that this came out as 20 weeks. In this instance, like, let's pretend that this is the example I showed earlier of that O2 experiment. If we had only included those 5,000 users a day who were actually clicking into that button, the experiment would have taken 20 weeks for us to be able to detect a 2% lift in conversion rate. So it wasn't actually an experiment that was worth running, and it would take an unreasonable amount of time for you to be able to make a decision and learn from what you were doing. So that's a simple way of looking at it. In terms of then actually looking at and interpreting some results. So the theory here, and I kind of alluded to this already. So when you're looking at an experiment result, you always have the number of users in the test, and there'll be the number of users in the variant and the control. So if there's two, or if it would be sort of a V0, a V1, and a V2, if you had 3 variants, there'll always be the number of conversions that you've looked at. Generally speaking, looking at users, not session-based metrics, not visits, and looking at conversions. Conversions is a much better metric than click-through rate or clicks. So if you have the choice to look at conversions, please do look at conversions. If you are on a site where the only thing that you can use is subscriptions, people who sign up, people who click, people who get so far through the funnel, like I know in a lot of financial institutions or in telcos, sometimes you can only look at the top of the funnel, and you only later know whether someone converted because the rest of the funnel you maybe can't influence through A/B testing, or you don't have access to the analytics there. So seeing if you can get conversions, if you can, calculate conversion rate, so that you've got your conversion rate for each variant, and then the lift is the relative change between those two. So the conversion rate of the variant minus the conversion rate of the control divided by the conversion rate of the control, and that will give you your relative uplift. And then your A/B testing tool will also give you what's called statistical significance or confidence value, which comes from a p-value. The p-value comes from the statistical test that's being run behind the scenes. So like I mentioned before, if it was a z-test, a t-test, or a chi-squared test, something like that, if the p-value is 0.17, then the confidence is 1 minus that, so it's 83%. And in this instance, actually, if I had set 90% as my statistical confidence value that I wanted to achieve, I would not yet be confident in this experiment, so I wouldn't have rolled it out if I had gotten this result. That's an example there where you've got the 83%. So if we look at an example of a test result, I got Convert to send me this screenshot so that I could demonstrate like a real dashboard rather than one I just sort of hunted for on the internet. So you can see here that you've got the users or visitors. Different people use different language for the same things, but users and visitors generally mean the same thing. So Adobe says visitors, but other tools say users. I think Optimizely says users. So it's, swings and roundabouts which tool you're using, but different people mean the same thing. Conversions, conversion rate, uplift or improvement. So you can see here there's a slight difference in the language that we're using, and then the confidence level. And I can see here that because this test result is so early, no confidence level has actually been reported in this interface. But you can see the little box plot that's showing that the confidence interval is slowly separating from each other, and those two results are getting further and further apart. And it looks like this is very, very negative. However, there's only like 4 conversions in one and 5 conversions in the other. So if I was interpreting this experiment result, if I had already sample sized this test and it had said that I need 20 days, and this was day 1, I probably would just let this sit. I wouldn't go, oh, it's really negative. Oh, it's minus 40%. I wouldn't do that. I would let it sit, because I can also see that the increased engagement and decreased bounce rate, they're both doing different things. They're going in very different directions. They're both things I wanted to monitor, but they're very, very early on in the experiment runtime. 50 users per variant is like nothing. I don't know which page this was running on, but if you needed 5,000 unique visitors per variant or 20,000 unique visitors, we used to have a sample size rule of thumb, which was 75,000 unique visitors, which meant about 3 weeks of trading when I was working in-house. So that's a good way of thinking about it. Like, can you capture everything that happens in a month? So if you run it for a month, you can see, especially if you're a subscription-based business or a B2B business, actually looking at the complete cycle within a month and including that all within your test period so that you've got it all captured. That might be an important thing to think about when you're sample sizing. So that's looking at early days of an experiment result. And then I've got an example here from actually when I was in-house at Photobox. And you can see this first test has only been running for 6 days. And there's 3,000 unique visitors and 3,000 unique visitors roughly. And there's 22% increase in conversion rate, 99% confidence. And that looks amazing. That looks like, oh, I should definitely roll this out. This result is definitely looking really good. But I know, looking at those numbers, that I haven't collected enough sample yet. That is nowhere near the sample size that I pre-sampled for this experiment. I know that I needed about 30 days of data. And you can see further down, the third row down, where this test shows that it's been running for 34 days, and there's 35,000 users per variant. 3.22, that sounds more realistic, doesn't it, than 22.5%, and it's to 99% confidence. So I can see there that actually I collected enough data because it's approached my sample size that I set before I launched the experiment. And so this is one way that you can think about how to compare all your different results that you might see inside your A/B testing tool when you're looking at all your different tests that are running. And actually, even though some of them might be showing, oh, I'm achieving confidence, actually making sure that you've already sample sized and that you're looking through your data correctly. So I think that pretty much comes to the end of what I was going to say, unless, Eddie, you have some specific questions on the last couple of slides that I presented.
No, I do. So the example you showed before, there was a 99% confidence. Wouldn't the confidence measurement take into consideration the size of the audience in order to be?
That would be the power. So, right? So power helps you, yeah. So this experiment is what I would call underpowered. So I haven't collected enough. I haven't collected enough sample in this experiment yet. And so I know that it's underpowered. So one thing you could do, and it's not listed here, is you could do a power calculation that would show that it was at like 30% power. So
that way you have both and you can say, okay, is this enough? Is it not enough? Or should I trust this confidence or not? So they should go together, right? Not separate.
Yes, but people are really not used to looking at that as a statistic. I know some A/B testing tools intentionally hide the confidence level from you and the result, or they hide the result from you until the confidence and the power is over a certain level. And also some A/B testing tools have played around with their internal stats engine to make it more intuitive to look at these results. So actually, I think the example here, no confidence has been given, right? Even though there's a confidence interval being calculated, but no confidence has been given because this is such an early days experiment result that actually a confidence level probably shouldn't be reported for this experiment. So I suspect that's probably something that you guys have built into your tool, and that's why there's the little question mark, which sort of helps explain what confidence is and that kind of thing. So if you hover over it. Sorry, I'll just scooch back ahead again. So you could have it in here. And when we were doing this results panel production, when I worked at Photobox, we thought about adding it as a column, but we realized our product managers were getting confused enough as it was. So the actual thing that we did instead is we started plotting test results and showing the cumulative confidence over time. And if it's wiggly all over the place, then it's a non-significant result. So it might be that this one day of this week, it was over 90%. And then the next day it went down to like 50% and then back up to 90 and then down to 50. That actually means it's a non-significant result. But if it takes a curve and goes over 90 and stays over 90, then you know it's a statistically significant result because it's staying above that 90. So that's another way that you can look at it.
All right. Good. Thank you, Ellie. That was my last question. I think the highlight here is sometimes you have to embargo some metrics in order for your experiment to run without anybody saying pull the plug, which often happens. So yeah, keep that in mind. I learned something. So confidence and power; those two are quite interesting. Thank you, Ellie, for that. I don't believe we have any questions. I must mention that we had Vlad on the controls today from Team Convert. Thank you, Vlad, for helping us out, field these questions out. And I think Sophie just submitted a question. So let me read that one. Sophie says, you mentioned the O2 example you gave was not worth testing. If you encounter the same case today, would it mean you would not run the test at all? Would you propose an alternative test? It just seems that a significant amount of areas on the website would then be not testable.
It's a good question. I think there are times when, if you're on a smaller traffic site and you believe something is a good idea, and there doesn't seem to be a really strong downside to the idea. So this particular idea, other than the fact that fewer results were shown in that unit, you could have probably just rolled that out. I know we're not meant to suggest that, but I think under certain circumstances, it's fine to roll it out if you know that you don't have an easy way of being able to test it and you don't think it's going to have a massive impact on conversion rates or your revenue numbers. I think the time to really care is when you're making a massive change to the site. So if you are on a smaller traffic site, you should be aiming for much bigger test ideas. Or if you're on a site that has large volumes of traffic but low conversion rates, again, you need to be picking really, really radical ideas. Like I was working a few years ago with a specific part of a larger brand. So imagine a large real estate brand, and they had launched a specific small product, which was from an acquisition inside their company. And this particular one, didn't have a website for it. So it was a brand new website they were just launching. And the number of users who were visiting it was really, really low. Had quite a good conversion rate, but it had a very, very low number of visitors. So for the first 6 months that they launched, actually, they weren't A/B testing at all. They were just rolling out new versions of the experience and then monitoring to see if the number of back-end conversions went up or down. So they had a really clear idea on the back end if the number of people who got certain types of quotes from them or the number of people who paid for the product that they were selling went up or down. And that would, if they rolled out something very negative, it would immediately go to like 50% if it was bad, or it would double overnight if it was really good. So that's an example where they knew there was no point in trying to like fiddle whilst Rome burns. They needed to actually get results straight away. And then once they were more established and they had a little bit more traffic, more consistently people visiting the site, that's when they were like, oh, we can run a couple of A/B tests, but they again still need to be like massive, big changes so that they could see the results straight away. So I think that's something that I always give people as advice. It's almost like saying you need to go down to the shops and it's 2 minutes on foot, but 10 minutes in the car. would you get in, unless you're carrying something very heavy that's really
Yeah.
worth carrying in your car, would you nip to the shops in the car? No, you just need to buy some milk, so you just pop around the corner, right? So I would say use the tool that's right for the moment. If you're doing something quite small, like I had someone ask me once, oh, we want to put this one line of copy in the checkout that explains to people what happens when their delivery is delivered. I was like, but everybody needs to know that, right? And they were like, yes. And I was like, so just
Yeah,
roll it
it's
out
a
as one
quality
line of
of life
copy.
improvement instead of like
Yeah.
like a proper hypothesis. Which
Yeah.
I actually wanted to ask you, Ellie, in that scenario you mentioned where you were rolling out this incremental changes or iterations when you didn't have enough traffic and measuring it in the back end, the performance, would that still be considered CRO, or is that a different type of testing, or how would you define that?
Um, Well, I've worked in businesses before where we've only taken conversion rate from the back end. So we've not done it all in the front end tool, and that can be more accurate. So actually at Photobox, we would use unique visitors from Google Analytics, and then we would take conversions from the order system, and then we'd join it
Mhm.
together on user ID. And it meant that we weren't then overestimating bookings, because sometimes your front end web analytics tools can overestimate bookings. But
Mhm.
also these days they're affected by things like consent, anonymous users, all the
Attribution, yeah. Mhm.
and all that kind of stuff, cookies, everything that's happening on the front end. So your unique visitor numbers will be naturally a bit low compared to actually if you could get the total number of people who are available. But the back end order numbers, that that's correct because people have physically ordered a physical product from you, or they physically booked a cruise and they're going on a cruise. So that's one reason to use those two together. It's more complicated though. The nice thing about, let's say you had spun up Convert on your site, you could look at unique visitors and conversions if you'd set up that tagging correctly all in one system. So there are some advantages to doing it in a single system. The time to use more complex methods to join data together is where you know that you're being hit very badly by consent and you're losing a
Mhm.
lot of unique visitors in your web analytics tool. Or if there's something specific about the type of product that you sell, that you have to have really accurate order numbers for your conversion rates. But we found that meant that also helped with things like calculating margin and actually
Yeah.
offering margin numbers. So to answer Sophie's question, or sorry, Suzanne's question from earlier, because we were using back end numbers and back end revenue, our revenue estimations of how much money our tests made when we rolled them out was much better because we weren't using what Google Analytics had told us. I know I'm sort of trashing Google Analytics, but it's not meant to be. It's
No,
just
I
it
mean,
can't help
you
it.
can, but you can change the name of the tool in that case. I mean, analytics are what they are. It's just one source of truth, but you have to make sure that everything is QA properly so that it's reporting properly. But even then, you will still have some nuances when it comes to tracking. I think that's one of the lesser highlighted things during the presentation was the importance of QA, right? And making sure that whatever you're launching is QA properly, knowing that it's reporting well, so that tomorrow you can interpret the results properly, right? So Ellie, we are about to run out of time, and I know you had a little bit of a you wanted to mention something about how can people connect with you, in what is the best way of communicating with you?
So people can connect with me on LinkedIn. So this is my QR code for LinkedIn. Also, in the email that goes out to everyone who signed up afterwards, you'll get the recording. I think you'll be able to watch it live from LinkedIn, right? But there will be a link to the recording sent. But we're also going to send a page a little bit like this one, which will give you a complete summary, the total resources, everything that's been mentioned today, all those random things that I mentioned and I linked to or mentioned a resource for, that will all be on the page. And then you can also book free coaching with me, which is worth £120. So you can book that session in and stuff as well. And there'll be a book button on the page. So if anyone has subsequent questions where they're like, I'm still stuck and I still don't understand, or you didn't answer my question properly and I want to interrogate this more thoroughly, you can go through there and book with me. So,
It's a
yeah.
great offer, Ellie. Appreciate you. Thank you so much for taking the time to walk us through some of the basics. Again, it was a great refresher and actually very good feeling to be back in school and learn these things again or learn new things. So with that said, thank you so much for the session. And I hope to catch you again in another session that's more advanced, where we cover other basics for CRO. Have a great day, and I look forward to meeting you again sometime soon.